Hello everybody. In this video we're going to use a rotary encoder, an I2C LCD, and an RGB LED. We're going to use the encoder to be able to select what color we want to adjust, and by clicking the button we'll go into a second mode that will allow us to adjust each one of those colors and the level of it. That's going to affect our overall output going to the RGB LED. Let's get started. Okay, let's go ahead and go over a code. So we're going to start out with our title block. We're going to name our sketch, who made it, the date, general purpose. Now for the good stuff. So we're going to include a library called LCD I2C.h. If you do not already have this on your computer, go up to the Tools menu, go down to Manage Libraries. If you run a search for LCD I2C STE, that will bring up this one here. So this one is made by Stefan. I've used it in the past, using it now. Love it, highly recommend it. So yours should say install. Just go ahead and click that install button and that'll get it installed on your computer. Mine says remove because I already have it installed. Then next, we are going to go ahead and tell it how many rows and columns we're using. In our case, it's 4 and 20 columns. Next, we're going to create an instance of our LCD and we're going to call it LCD. We also need to tell it what address our LCD is on. So with I2C, if you're using an LCD with the I2C piggybacked board on the back, we can actually have multiple addresses and use multiple LCDs. So if these pins here are not soldered or jumpered in any way, chances are you're going to have the default value of 0x27. So check your documentation. Going too far into depth on that, that's for a whole nother video, but chances are you're probably going to be 0x27 as well. So next we're going to go ahead and set up a bunch of constants of type byte. We need 3 pins for our encoder, and that's going to be clock pin, data pin, and switch pin. We're going to set those up on digital pin 2, 3, and 4 of the Arduino. Then we're going to need a red LED, green LED, and blue LED pins going to 5, 6, and 9 of the Arduino. So we're going to set up a bunch of variables for the encoder position, the previous encoder position. We need to set up some limits here. So for mode 1 encoder high limit, mode 1 encoder low limit, mode 2 encoder high limit and low limit. So what we're doing here is for mode 1, we're going to be able to select what color we want to use. So we're going to select 1, 2, or 3, red, green, or blue. We need a high limit of 3 and a low limit of 1 so that we always have something selected. Then when we click the button, and we've chosen what color, let's say we go to green and we click the button, now we're in mode 2. Now we can adjust that value. We need a high limit of 255 because PWM or pulse width modulation goes from 0 to 255. Next we need some unsigned long variables for previous millis and current millis, and we need an integer for millis delay time. We got that set to 5 milliseconds. These 3 variables we're going to be using to debounce the interrupt when we're reading from the encoder. Then we need to keep track of what our current values are of our red color position, green color position, and blue color position. We need to store that value so when we go to something else and come back to it, it remains there. Then we need to know what color we currently have selected. So we're going to use this 1, 2, and 3 for red, green, or blue. We need to know what mode we're in, so 1 or 2. Then we're going to have an integer for turn interval. So what that is as we're turning the encoder, let's say to the right to increase our value, for every click of the encoder, it'll go 10 points. That way we can get to that high limit of 255 a little quicker. If we set this to 1, then we have to turn and turn and turn to try to get there. Next we have a couple of arrays set up. One is we're calling cross and the other one arrow, and these are for special characters. I'm going to do another video here shortly where I'll go more into detail with that, so make sure you hit the subscribe button. That way you're notified when that video comes out. But for right now, we're not going to go too far into detail on that. So in the setup function, we're going to start by starting or beginning our LCD. We're going to tell it how many rows and columns. Then we're going to attach our interrupt to be looking at the encoder. So we're going to do a digital pin to interrupt. We're looking at pin A, which is the clock pin, and we're looking for that to go low. When that goes low, it's going to run this halve rotation, which is the interrupt service routine. Our halve rotation is down here, and we'll go over that in just a minute. So next we can, I've got commented out, but we have the serial monitor. So we're going to begin the serial monitor so that we can do any kind of troubleshooting. Right now that's commented out. Then we need to set up some modes. We need to tell it what our pin modes are. Pin B, or our data pin of the encoder, is going to be an input. Our red, green, and blue pins for the LEDs, those are all going to be outputs. And then we're going to do a digital write to each one of those pins, and we are writing high. This particular RGB LED is a common anode. So in order to get it to light that color, we have to send it a low signal. If we send it a high signal, it is actually going to go off. So we're starting all three of these in the off position. Our next line here, we're going to create that special character. In this one, we're going to call it 1, and it's going to be that cross that we did the array up top with. The next one, we're going to create another special character, number 2, and that's going to be the arrow. Then we're going to turn our cursor off on the display. And next line, we're going to locate row 1, column 2, and that's where we're going to print the words red, green, and blue. Then we're going to put a special character in. We're going to go into row 2, column 3, and we're going to put in 1, which we created 1 to be the cross. All right, next let's go ahead and go through our loop. So in our loop, we're going to take a snapshot of the current time. So our current millis is going to be equal to the results of running the millis function. Then we're going to take a look at our switch. So on an encoder, the switch or the button is always high. We are looking for it to go low. If it goes low, we're going to run the function switch is pressed. So that's why, because we're looking for it to go low, that's why we have a not symbol in here. We're looking for if not digital read switch pin, and then it'll go to switch pressed. So next we're going to be also looking at the if encoder position is not equal to previous encoder position. This is basically going to tell us that we are turning the encoder. If we are turning the encoder, we're going to run the function set encoder limits. We'll get into that in just a minute here. If we're in mode 1, we're going to go ahead and clear row 2. So if there's any crosses previously on there, we're clearing them all off. Then we're going to look at what our encoder position is. If it is 1, we're going to set our special character in row 2, column 3, and the character we're going to use is 1, which was the cross. If the encoder position is 2, then we're going to set the special character in row 2, column 10, and if it's 3, we're going to set it in column 18. So basically we're putting that cross under the red, green, or the blue. Next we're going to look at if we're in mode 2. If we are in mode 2, we're going to clear row 3. So if there's any previous numbers under any of the colors, we're going to wipe those out, and we're going to start from scratch. We're going to look at what color selection we have. If we're at 1, we know we're at red. So we're going to locate row 3, column 3, and we're going to print red color position. If our color selector is at 2, then we're going to go on the LCD row 3, column 10, and we're going to print the green color position. Same thing with 3 for the blue. Next, we're going to move our encoder position to the previous encoder position so we can keep track of it next time we come through the loop. Then when we get to the end of the loop, we want to go ahead and write whatever those color values are. We're going to write those two with an analog write to each one of the LEDs. We're doing a 255 minus that position because this is a common anode. So it's actually reverse of adding to the 255. Hopefully that makes sense. I actually have this line in here twice, and I'm not real sure why. I think I can remove this one. But it shouldn't hurt anything. Basically, we're taking the encoder position and moving it to the previous encoder position again. Now let's go ahead and take a look at the have rotation, which is the interrupt service routine. So we're going to start out by doing a little debounce here. We're going to say if current millis minus previous millis is greater than our millis delay time, which we set at 5 milliseconds, then we can continue. But if it's bouncing on and off real quick, it hasn't made it past that 5 milliseconds, then it's going to ignore this and wait for the next time. When this gets called, our pin A or our clock pin has gone low. So first thing we're going to do is look at our data pin on pin B and see what that is. If it's 1, then we know we're going clockwise, and we're going to, if we're in mode 1, we're going to set the encoder, we're going to increment it, and we're going to set our color selector to whatever our encoder position is. If we're in mode 2, then our encoder is going to be equal to our encoder position plus that turn interval, in which case we've set that at 10 currently. By doing so, this way we're moving the value of each color up. And then if our color select is 1, or we're looking at the red position, then we're going to adjust our red color position to whatever the encoder is sitting at. Same thing with our green and blues with color select 2 and 3. Then we're going to go back and look at our digital pin B again. If it is 0, then if we're in mode, we're going to decrement our encoder. Basically, we're doing the same thing as we just did, but in reverse because we're going counterclockwise instead of clockwise. Then when we get to the end of our have rotation function here, we need to store our current millis in the previous millis variable as well. Okay, let's go ahead and take a look at what happens when we press the button on the encoder. So we're going to run the switch pressed function. We're going to look to see what mode we're in. If we're in mode 1, we're going to switch to mode 2, and then whatever color is selected, whether it's the red, green, or blue, color select 1, 2, or 3, we're going to take that value that is currently stored and move it back to the encoder position so that we can adjust the encoder position as we're moving the encoder. And then if mode 2 was selected, we're going to clear row 3 of the display. So we're taking all of those numbers 0 to 255 off because we're going back to mode 1 where we're going to select the colors. Then we're going to move our color selection to encoder position so that we can adjust that 1, 2, or 3 again. Then we're going to run a very short delay of 400 milliseconds. This is just a way to debounce us pressing that button. Now let's take a look at our final function here, and this is where we set the encoder limits. If we're in mode 1, we're going to look to see if encoder position is greater than our high limit. If it is, we're going to make encoder position our high limit, so it can't go any further. Anytime it tries to go further, it just sets it at that high limit. Same thing with going the negative direction. If encoder position is less than encoder low position, then we're going to set the encoder position variable to be equal to our low limit. Then if we're in mode 2, same thing's going to happen, but now we're using our mode 2 variables. Now the next few lines, above and beyond our encoder position, we also have our red color position, blue color position, green color position, and we're going to set those limits as well. So if our red color position goes lower than our low limit, we're going to set it to 0. If it goes higher than our high limit, we're going to make it our high, and we're going to do that for each color. And that should do it for our code. Let's go check it out. So now we can take our rotary encoder and our LCD and we can select a color. We can go into our second mode. That allows us to adjust that color. And then we can select another color and adjust it as well. So if you've learned anything from this video, if you've enjoyed it, please hit that like button and go ahead and subscribe. I got a lot more videos coming out. Thank you guys for watching, and y'all have a good day.